In the first video, you saw the different ways that hydrocarbons can change by making rings and adding double or triple bonds. This video focuses on 4 common functional groups containing oxygen atoms. Each of these functional groups has its own characteristic chemical reactions and behavior. As introduced in the first video, R means any hydrocarbon. So let's get started. An alcohol, such as the ethyl alcohol in hand sanitizer and the isopropyl alcohol in rubbing alcohol, contain an OH group. You might see -OH or you might see -O-H. They're equivalent. Alcohols are common solvents. If we remove the hydrogen atom and add another bunch of carbon-hydrogen stuff, the molecule becomes an ether. Ethers are also common solvents. A long time ago, diethyl ether was one of the first anesthetics. Unfortunately, it is super flammable. Also, the dose required for anesthesia and the fatal dose are very close to each other. Diethyl ether is no longer used as an anesthesia, but ethers are found in a number of substances. Carboxylic acids are the third type of functional group. Like alcohols, they have an OH, but they also have a C double bond O, called a carbonyl, on the same carbon atom. Carboxylic acids are also called organic acids. They include the many types of acids found in foods, such as acetic acid in vinegar, citric acid in citrus fruits, ascorbic acid, which is vitamin C, malic acid in apples and grapes, and tartaric acid found in grapes, bananas, and other fruits. If we remove the hydrogen atom and add another bunch of carbon-hydrogen stuff, the molecule becomes an ester. Esters are common flavors and fragrances. Esters provide the flavor of wintergreen, banana, peach, cherry, and others. They're also used in antifreezes and have other industrial uses. These are additives in hair products. Let's identify the functional groups. In Figure 1, there is a benzene ring. It is aromatic. There's also a nitrogen-containing functional group called an amine, but we aren't going to worry about these. In Figure 3, there's an ester right here. In Figure 5, we can see the OHs, which are alcohols. Figure 6 has an amine and a benzene ring and an alcohol. At the bottom of the page, the oxygen-containing functional groups are conveniently marked in red. We have esters here and here. There's a carboxylic acid in this center molecule and an ester and an alcohol on this molecule on the left. There are also some alkene double bonds in each of these molecules. Try to identify the functional groups on the next page. This is a carboxylic acid. This one is an ether. In this structure, the other 4 corners of the pentagon are carbon atoms, and the hydrogen atoms are implied. Identifying the benzene ring in this one is easy. It also has an alcohol down here and a carboxylic acid over here. In the second row, this alkene has an alcohol group. Note that it is not an ester because we don't have a C double bond O. The oxygen between the carbon atoms is an indication of an ether. And this last one in this row is an alcohol. The third row starts with an alcohol. The center molecule has an ester right here. It looks backwards, but it's still an ester. And this final molecule is aromatic with an alcohol group. The fourth row has an ether, a carboxylic acid, and a molecule with 3 alcohol groups. And the last row has methyl salicylate, commonly called oil of wintergreen, which has a benzene ring and an ester and an alcohol, followed by a long molecule with benzene rings, alcohol functional groups, and an ester. It also has an alkene, but we didn't ask for that one. So alcohols, esters, ethers, and carboxylic acids are functional groups that dramatically change the behavior of hydrocarbons. Your task will be to identify them through matching names with structures, and I hope this helped.